You hear it before you understand it. A scream cuts through a crowded street, and every head turns at once. Nobody decides to look. Nobody has time to think. Your body moves before your mind catches up, and for 1 second, you are not you anymore. You are 200,000 years of instinct, reacting to a sound your ancestors never stopped fearing. It doesn't sound like other noises. A car horn is loud. A dog barking is loud. But a scream does something different to your brain, something almost violent, and scientists have spent years trying to figure out why. In 2015, a neuroscientist named Luc Arnal set out to answer that question. He and his team at NYU recorded human screams and ran them through detailed acoustic analysis, comparing them to speech, singing, and everyday alarms. What they found was strange. Screams occupy their own acoustic space. They are rough, jagged, full of rapid, chaotic shifts in loudness that happen dozens of times per second, a quality researchers call roughness. Normal speech doesn't have it. Music, even the most intense music, rarely comes close. But screams are built almost entirely out of it. Here's where it gets interesting. Arnold's team didn't stop at screams. They tested how people responded to alarms, car horns, and even synthetic sounds engineered to be jarring. None of them triggered the same reaction. Only sounds with that rough, chaotic quality lit up the fear centers of the brain the way a scream does. Your brain isn't just reacting to volume. It's reacting to a very specific pattern, one that seems to have been selected for generation after generation because it works. Think about how unusual that is. Volume alone doesn't explain it. A jet engine is louder than a scream, but it doesn't trigger the same spike of dread. A thunderclap can rattle windows, yet most people flinch and move on within seconds. It isn't loudness your brain is scanning for. It's texture. It's chaos. Somewhere in your evolutionary past, a very specific acoustic fingerprint got flagged as an emergency signal, and that flag has never been erased. Arnold's team pushed the experiment further. They took ordinary human voices and artificially added roughness to them, layering in those same rapid, jagged fluctuations found in real screams. The result was unsettling. Even calm sentences, spoken in a neutral tone, began to feel threatening once that texture was added. Meaning didn't matter. Words didn't matter. The raw acoustic pattern alone was enough to unsettle listeners in a lab, sitting in a quiet room, with no actual danger anywhere nearby. Why would evolution build a sound like that? Think about the world your ancestors lived in. No streetlights, no phones, no way to send a warning except with your own body. If a predator appeared at the edge of camp, there was no time for words, no time to explain. What was needed was a sound that could not be ignored, a sound that skipped straight past the thinking brain and went directly into the part of you built for survival. A scream does exactly that. It hijacks attention immediately, cutting through fatigue, distraction, even sleep. That's not poetic language. It's closer to literal biology. A second researcher, Sascha Frühholz at the University of Zurich, looked directly at what happens inside the brain when people hear a scream. Using brain imaging, his team found that rough, screaming type sounds activate the amygdala, the almond-shaped structure deep in your brain responsible for detecting threat, faster and more strongly than almost any other stimulus tested. Faster than a spoken warning. Faster than a shout of a word like danger. The sound itself, stripped of all meaning, was enough to trigger the alarm. Your brain didn't wait for language. Language came later, evolutionarily speaking. The scream came first. Frühholz's team went even deeper. They didn't just confirm that screams activate the amygdala. They mapped out how quickly the signal traveled and compared it against dozens of other emotionally charged sounds, including crying, laughing, and even other people's voices raised in anger. Screams still came out ahead. They triggered a stronger, faster, more automatic response than almost anything else in the entire test set. It was as if the brain had built a separate, dedicated fast lane, one reserved specifically for this single category of sound, bypassing the slower, more deliberate circuits used for everything else. That distinction matters. Most of what you hear in a day gets processed the normal way. A voice, a question, a joke. Your brain takes it in, considers context, decides how to respond. But a scream doesn't go through that same cue. It skips the line entirely. It goes straight to the part of your brain that existed long before humans had words at all, the part shared with almost every mammal that has ever needed to survive a predator. That's the part worth sitting with for a moment. This response isn't uniquely human. Rodents freeze at ultrasonic distress calls from other rodents. Primates scatter at the specific alarm calls of their troop. What Arnal and Frühholz's research suggests is that humans never fully left that system behind. Underneath thousands of years of civilization, underneath language, art, and cities, there is still a very old, very animal circuit quietly running in the background, waiting for one particular pattern of sound. This is where the story gets stranger and more personal, because your brain still runs on that same old software. You don't get get a modern operating system just because you live in a modern world. You are still carrying prehistoric wiring inside a smartphone-era skull, and every time a car alarm goes off, or a smoke detector shrieks, or a toddler starts crying at 3 a.m., you feel that same jolt. Your heart rate spikes. Your muscles tense before you've consciously registered why. That is 200,000 years of pressure compressed into a fraction of a second. Even Charles Darwin noticed something like this, long before neuroscience existed to explain it. In 1872, in a book called The Expression of the Emotions in Man and Animals, he observed that fear responses to sudden, sharp sounds looked remarkably similar across cultures, across ages, even across species. A baby recoils from a scream the same way an adult does. A person from one side of the world reacts almost identically to someone raised in an entirely different culture. Darwin didn't have Arnal's spectrograms or Frühholz's brain scans, but he saw the pattern with his own eyes. Fear of that sound wasn't learned. It was inherited. So what does that mean for you? Sitting here right now, far from any predator, far from any real danger. It means the wiring never left. It just found new triggers. Modern engineers, whether they know the research or not, have leaned into this same instinct. Car alarms are built with irregular, jarring pulses. Smoke detectors use pitch shifts specifically because smooth, even tones get ignored, but rough, chaotic ones cannot be tuned out. Ambulance sirens wail instead of holding a single steady note, precisely because a wavering, unstable sound cuts through traffic noise in a way a flat tone never could. None of this is accidental. Somewhere along the way, someone noticed that people respond to chaos faster than they respond to clarity, and safety systems around the world were quietly redesigned around that single fact. Even horror movies exploit it directly. Sound designers deliberately layer human screams, distorted animal cries, and rough textures into a film's climax because they know, whether through instinct or research, that the human brain cannot casually shrug off that particular pattern of sound. You don't choose to jump in your seat during a horror movie. Your amygdala makes that decision for you, in less time than it takes to blink. Composers have learned to hide screaming frequencies inside orchestral scores, burying them under strings and brass so faintly that most viewers never consciously notice, yet their pulse quickens anyway. You walk out of the theater convinced the plot scared you. Often, it wasn't the plot at all. It was the frequency. Video game designers use the same trick. Jump scares rarely rely on visuals alone. Strip the audio out of almost any viral horror game clip, and the fear collapses instantly, no matter how unsettling the monster looks. The image needs the sound to work. The sound barely needs the image at all. There's something almost humbling in that. You like to think of yourself as rational, in control, a modern person who reads, reasons, plans. But underneath all of that, there is still a very old alarm system, tuned by hundreds of thousands of years of survival, waiting for one specific pattern of sound. It doesn't care about your job, your plans, your sense of control. It only cares about one question. Is this the sound that means danger? And when that sound comes, whatever you were doing stops. Think about the last time you heard a scream, even a small one. A child startled on a playground. A jump scare from a phone speaker. Someone shouting in surprise 2 rooms away. For a fraction of a second, before your rational mind caught up and explained the context, your whole body reacted as if something was actually wrong. That reaction wasn't a choice. It was inheritance. It's strange to think that the very first alarm system humans ever had is still installed and running quietly underneath every calm, ordinary day you live. You don't need to fear predators anymore. You don't sleep in the open, exposed to the dark the way your ancestors did. But your brain hasn't been told that the danger is gone. It still treats one particular pattern of sound as a 5-alarm emergency, because for most of human history, ignoring that sound meant you didn't survive to pass on your genes. That's the twist most people never think about. You assume fear is something you learn. You assume it comes from experience, from being taught what to be afraid of. But this particular fear didn't need a lesson. It didn't need a bad memory or a traumatic event to plant it. It was already there the moment you were born, sitting quietly in your amygdala, waiting for one very specific pattern of chaos and roughness to activate it. So the next time you hear a scream, real or on a screen, and you feel that jolt before you understand why, remember what's actually happening. You're not overreacting. You're not being dramatic. You are running a piece of software older than language, older than fire, older than almost everything you consider human. You hear it before you understand it. And maybe that's the point. Maybe understanding was never supposed to come first. For 200,000 years, survival depended on reacting before thinking, and that single sound, more than almost anything else in the human experience, is the one your body has never stopped listening for.